Hi friends, my name is Apparao, working as Associate Professor in Computer Science and Engineering Department at Marri Laxman Reddy Institute of Technology and Management, Dundigal, Hyderabad, Telangana State. So in this session, I am going to discuss about Advanced Computer Network course. So in this Advanced Computer Networks course, just I want to discuss in this session, so data link protocol. So in Advanced Computer Networks, just I want to discuss about course objectives and course outcomes. So later I'll discuss about unit wise session plan like unit 1, unit 2, unit 3, unit 4 and unit 5. So first of all, in Advanced Computer Networks, so course objective in the sense, this course aims to provide advanced background on relevant computer networks topics. So as I discussed earlier, now in computer networks, there are a few basic concepts are available. So in this course, just I want to discuss advanced background and relevant computer networking topics to have comprehensive and deep knowledge in computer networks. So this is the main course objective. So after completion of this course, just we can get the outcomes. Understanding of holistic approach in computer networking, ability to understand the computer network protocols and their applications. As we know that protocols are really important, especially in computer networks. So in advanced computer networks also, just we want to discuss about computer network protocols and ability to design simulation concepts related to packet forwarding in networking. So packet forwarding plays a major role in advanced computer networks. These are the three course outcomes in computer networks. So in this advanced computer networks, so these are the first unit. This is the first unit. So in this unit, just I want to discuss data link protocols, Ethernet, token ring and wireless. So wireless networks and mobile IP. So later infrastructure of wireless networks. Next wireless LAN technologies. So IEEE 802.11 wireless standard, cellular networks, mobile IP, wireless mesh networks also called as WMNS, multiple access schemes, routing and internetworking, network layer routing, least cost path algorithms, non-least path algorithms, intra-domain routing protocols, conjunction control at network layer. So these are the topics I'll cover in the unit 1. So in advanced computer networks. So unit 2 I'll discuss, unit 3 I'll discuss, unit 4 also I'll discuss. So in the end I'll discuss about unit 4 also. So now, so these are the textbooks available in advanced computer networks. Computer networking, a top-down approach by James. Computer networks and internets, Douglas E. Comer, 6th edition. So this we can prefer. So reference books, a practical guide to advanced networking, computer networks, Andrew S. Tenenbaum. So this we can refer. So for this video lectures, so I have taken some content from tutorialpoint.com and geeksforgeeks.organization. So before going to discuss about advanced computer networking topics, just I want to give an introduction. So the data link protocol operates in the data link layer, as we know that. So of the operating OSI model. So these are the main topic in computer networks, that is OSI, Open System Interconnections model, just above the physical layer. So before going to discuss about this data link layer protocol, just I want to give the 7 layers available in the computer networks. So first one is physical layer, data link layer, network layer, transport layer, session layer, presentation layer. In the top, so we have a application layer. So in the previous slide, data link layer protocol operates in the data link layer of the OSI model. So this is the first physical layer. So here, so in advanced computer networks, we start from the data link layer. So now see introduction. The service provided by the data link protocol may be any of the following. First one is framing, flow control, error detection and correction or correction. Next, multi-point transmissions. So these are the few services available in data link protocol. So first one is framing, flow control, error detection and or error correction. In the end, multi-point transmission. So now see framing. The stream of bits from the physical layer are divided into data frames, as we know that. So from the physical layer, so we have a few bits from the physical layer. So after forwarding from bottom level to next level, divided into data frames, as we know that, whose size ranges from a few hundred to few thousands bytes. So these frames are distributed to different systems. So by adding a header to the frame containing the address of the sender and the receiver. So for example, so to better understanding in computer science, computer networks, so have a sender and a receiver. Age old story it is. So now if you want to send a data from sender to a receiver, so obviously there are 7 layers plays a vital role, especially in the data link layer. The stream of bits from the physical layer are divided into data frames. Data frames. So that's the reason frames plays a vital role in the data link layer. So size is also very important, especially in the computer network from sending and receiving the data. So here whose size ranges from a few hundred to few thousand bytes. So range is also so higher than the physical layer. These frames are distributed to different systems. We'll discuss by adding a, so for each and every frame, so obviously we have a data address for each and every header. So we have to add a data header for frame containing header address and the sender address also required. So why this address? Suppose for example, so while transferring the data from source to destination, so if there any frame missing or else corrupted, so by using this sender address and receiving address, so then and there itself we can resend the frame from source to receiver. That's the reason frame address is also important, especially from data link layer. So into framing. So hope this one clear, right? Next, flow control. So through flow control techniques, data is transmitted in a such a way so that fast sender does not run a slower receiver. For sending data is also required. Suppose for example, so within the time period, so we have to send the data. Say if I send the data today, so if you receive the data tomorrow, it's meaningless, right? That's the reason flow control is also important, especially in data link layer. That's the reason through flow control techniques, data is transmitted in such a way so that fast sender does not down a slower receiver. Next one is error detection or error correction. So for better understanding, just I have a simple example. So this is sender and this is receiver. Suppose for example, so I want to send a hi message from sender to receiver. So while transferring the frames, having some sender address and a receiver address. So instead of hi, suppose for example, see if you receive the he, so there may be error, right? So sometimes it may happen. So that is called error correction, error detection. So error detection and correction, these are techniques of detecting and correcting data frames that have been corrupted or lost during the transmission. So while transferring the data, sometimes we may miss the data, so we may tamper the data, so sometimes we may delete the data. So how to receive the data? So by which using these concepts in the sense, so while transferring the data, so obviously there must be a one sender address and one receiver address. As this concept is called error detection and error correction. So these are techniques are detecting and correcting data frames that have been corrupted or lost during transmission. So last one is multi-point transmission. So access to shared channels and multiple points are regulated in case of broadcasting and LANs. So for example, so I have a LAN. So these are the few computers, LAN. So So this is a suppose server connected with some routing point. So access to shared channels, for example, channel 1, channel 2, channel 3, channel 4, and the multi-points also available. See, if it is a huge amount of channels, obviously we have to install some servers, right, or else multi-points. So regulated in case of broadcasting and LANs. So in these cases, so while transferring the data, see if there any data miss some channel, so by using that channel we can resend the data. So that's the reason. So multi-point transmission is also important. So another one is, suppose for example I have a data point here, data point. By connecting this there are a few channels. Suppose I want to send hi message to different channels. So in that cases also, so it multi-point transmission is also important. Now, so common data link protocols. So in this data link protocols, we have a common protocols available. So as we know that in computer networks, so we have a protocol concept. So protocol is a some set of rules given by the some organization or some governance, right? So in that cases, data link protocols. So these are the few protocols available, common protocols we'll discuss. Synchronous data link protocol, also called as SDLC. Next, high level data link protocol, also called as HDLC. Next is serial line interface protocol, SLIP, SLIP. Point to point protocol, PPP. Next, link control protocol, LCP. Next, network control protocol, NCP. So these are the common data link protocols: SDLC, HDLC, SLIP, PPP. Next, LCP. Next, network related protocol, network control protocol, also called as NCP. So these are the protocols we use in data link layer. So now we'll discuss what is SDLC, what is the work of HDLC. Next, importance of SLIP, importance of point to point protocol, LCP. Next, NCP will discuss. Now, synchronous data link protocol. So there is a few small history for this SDLC. SDLC was developed by IBM in 1970s as part of system network architecture. So network in the sense huge amount of channels available, right, with multi points. So if you want to share a data from one point to another point, so obviously we have a few concepts, right. So it was used to connect remote devices to mainframe computers. Suppose I have a source data, I have a source channel and a receiver channel, or else source and destination. So in between this, if you want to send a message from source to destination, obviously there must be a one data connection, or else there must be a one medium, either it is wire or wireless, right. So in these cases, mainframe computer, this is mainframe computer, assume that. So these are the remote devices. So here you can send and receiving the data from remote device to mainframe computer. So in this synchronous data link layer, so it was used to connect remote device to mainframe computers. So now they see data units arrive correctly and with the right flow from one network point to the next level. Suppose as we discussed earlier, no, sending messages and receiving messages should be same without any correction, or else so without any error. So in that cases we use synchronous data link protocol. So now high level data link protocol, also called as HDLC. It's a famous protocol, especially in data link protocol. HDLC used based upon SDLC and provides both unreliable service and reliable services. We'll discuss. So it is a bit oriented protocol, and that is applicable for both point to point and multi point communication. So example, so this is, let's consider I have a device 1 and device 2. This is point to point protocol. So another one is multi point protocol. So we can send hi message from the source. So at the same time same message will be received to different channels or else receivers. So that is multi-point. Next is serial line interface protocol. So this is a simple protocol for transmitting data units between the internet service provider, so we'll discuss, and home user over a dial-up link. So it does not provide error detection or correction facilities. So only one protocol, so we can see, so in that sleep, so there is no concept of error detection and correction. So in these cases, so let's consider, I have one example. So this is source and this is destination. So data units may be sent by using internet service providers. So without internet it may not work. So that's the reason I given the sentence called internet service provider. So nowadays we use serial line interface protocols only for transmitting the data. Next one is point to point protocol or else PPP. So this is used to transmit multi protocol data between two directly connected point to point computers. It is a byte oriented protocol that is widely used in broadband communication having heavy loads and high speeds. Suppose there are a service provider, so in that service provider, so within the fraction of seconds we may send large amount of data from source to destination. In that cases, so obviously we have a protocol called PPP, point to point protocols we may use. If it is a large amount of data, obviously, so we have to use only PPP protocols. That's the reason it is a byte oriented protocol. Next one is link control protocols. In one of PPP protocols that is responsible for establishing, configuring, testing, maintaining and terminating links for transmission purposes. LCP, link control protocol. Suppose for example, one of PP protocol that is responsible for establishing a connection. Suppose I have a two point to point networks in that connection. So first what I have to do? First establish a connection, next configuration. So next one is testing, so whether it is working or not. Next, after completion of this testing, maintenance is also very important. So if there any problem persists while sending and receiving the data, especially in advanced computer networks, so maintenance and terminating some links is also important for transmitting the data. So in that cases, obviously LCP will plays a vital role. It also imparts negotiation for setup option and use of features by the two endpoints of the links. So in computer networks, least bother about in between that communication. So in the endpoint of user, so sending and receiving also plays a vital role. So that's the reason setup options and use of feature by the two endpoints of the links. Last one is NCP. So that is network control protocol. So these protocols are used for negotiating the parameters and facilities for network layer. For every higher layer protocol supported by PPP, NCP is there. So obviously if there are any high-end protocols we'll discuss. These protocols are used for negotiating the parameters and facilities for the network layer. So what are the facilities? So obviously, so we may use routers, so hubs. Next one is router, hubs. Next one is switches. So these are the few network layer components or else facilities we may use in that cases. So PPP and NCP. So network control protocol and point to point protocols we may use. So if it is a network, so obviously, so these are the common data link protocols: SDLC, HDLC, LSLIP, PPP, LCP and NCP. Thank you for watching this video.